Good day. I'm Arjay C from BSIT2B. For the continuation of our Chapter 8 report, Implementation Support, together with my classmate Naja, Angeline, and Jeremy, we will now discuss and elaborate the section 8.3, or Programming the Application. If you remember the previous discussion of section 8.2, they talk over the elements of a windowing system, which contains the roles of a windowing system, its key features, and the generic language of an abstract terminal, which pertains to a window in a windowing system. They also mention the different software architectures, which varies in terms of management. X Windows architecture is the main architecture discussed, which is a good example of a client-server architecture that maximizes portability of a program application by having a server that manages even a distant machine or client. We now concentrate our attention on a programming the actual interactive application, which will correspond to a client in the client-server architecture of Figure 8.2. Interactive applications are generally user-driven in the sense that the action that the application takes is determined by the input received from the user. Now, to describe the two programming paradigms which can be used to organize the flow of control within the application, it will be discussed with my classmate.
So we now concentrate our attention on programming the actual interactive application, which would correspond to a client in the client-server architecture of Figure 8.2. Interactive applications are generally user-driven in the sense that the action the application takes is determined by the input received from the user. We describe two programming the paradigms. We can be used to organize the flow of control within the application. The windowing system does not necessarily determine which of these two paradigms is to be followed. The first programming paradigm is the read evaluation loop, which is internal to the application program itself. You will see in figure 8.4. Programming on the Macintosh follows this paradigm. The server sends user input as a structured event to the client application. As far as the server is concerned, the only importance of the event is the client to which it must be directed. The client application is programmed to read any event passed to it and determine all of the application specific behavior that results as a response to it. The logical flow of the client application is indicated in the leftmost box of figure 8.4. In pseudocode, the read evaluation loop would look like the following. The application has complete control over the processing of event that is received. The downside is the programmer must execute this control over every possible event that the client will receive, which could prove a very cumbersome task on the Macintosh. This process can be aided somewhat by programming tools, such as Mockup, which is automatic stop of the pseudo.
Dito po sa figure 8.5, the notification-based programming paradigm, the application program and for each event, pinapakita or dinedeclare niya po yung kanya-kanya nilang procedure or tungkulin as a callback or pinapakita ang dapat nilang gawin before turning control over the notifier or bago mag-step in sa susunod na process. Tapos, and if the notifier receive an event or gawain from the Windows system, makikita dito or mapaprocess kung yung event na yon was identified by the application program. Yung nakita nila. And if it is processed, the event, and it depends to the callback procedure, returns control to the notifier. Bale, it's either magkukontinue sila to receive another event or pwedeng mag-quit na sila at tapusin na yung program na yon.
So here is the notification-based program example. So the program that we will do is a simple program to display a panel button that says quit. Ayan. Selecting the panel button exits the program. So, from line 8, frame. Sa mga hindi familiar sa frame or frame is resizable, movable, independent, full with a title bar. So makikita niyo diyan. Yung frame na yon is yung box. Panel. Panel is the flow layout manager. Void. Void means this method doesn't return a value. It has to be defined in the method declaration. So, sa line 16, XV. So, mga hindi pa familiar sa XV, XV or XView is a widget toolkit from Sun Microsystem introduced in 1988. It provides an open-look user interface with an object-oriented application programming interface or API for the C programming language. So, init. What is init then? Yung mga hindi pa masyadong familiar sa code na yun. Init or initialization is the process of locating and using the defined values for variable data that is used by a computer program. For example, an operating system or user-specified values that determine certain aspects of the system on program is to function. So, frame label. What is label? Label displayed a single line of read-only text. So, ayan, makikita niyo dyan, yung quit na yan, yun. So, null in line 22. Null is a reserved word for literal values. It is literal, similar to true and false. The word null is case sensitive and we cannot write null, small letter, as null na malaki yung first letter or null na all capitalized. The compiler will not recognize error. Straightforward. Suppose the error condition occurred during the processing of an event of type recognized, the application then begins another read evaluation loop contained within that branch of the case statement. Within that loop, all non-relevant events can be received and discarded. In the notification-based paradigm, such a preemptive dialog would not be simple because the control flow is out of the hands of the application programmer. The callback produced would all have to be modified to recognize the situation in which the preemptive dialog is needed, and in those situations disregard all events which are passed to them by the notifier. Things would be improved, however, if the application programmer could, in such situation, access the notifier directly to request that previously acceptable events be.
Okay, going with agreeing. It is possible to use notification-based code to produce preemptive interface dialog such as a modal dialog box, but much more difficult than with an event loop-based system. Similarly, it is possible to write event loop-based code which is not preemptive, but again, it is difficult to do. So, if you are not careful, systems built using notification-based code will have lots of non-modal dialog boxes, and vice versa. Each programming paradigm has a grain a tendency to push you towards certain kinds of interface. If you know that the interface you require fits more closely to one paradigm or another, then it is worth selecting the programming paradigm to make your life easier. Often, however, you do not have a choice. It is in this case, you have to be very careful to decide what kind of interface dialog you want before you or someone else start coding. Where the desired interface fits the grain of the paradigm, you don't have to worry. Where the desired behavior runs against the grain, you must be careful both in coding and testing, as these are the areas where things will go wrong. Of course, if you don't explicitly decide what behavior you want or you specify it unclearly, then it's likely that the resulting system will simply run with the grain, whether or not that makes a good interface. So thank you for watching. So ang reporter is Arjay C, Angeline Maniaul, Naja, Andrada, and Jeremy Galang.